All right, team, let's get started. Our next design cycle is all about us mastering two incredibly demanding and very different electromagnetic environments. So today, we're going to break down the critical EMC compliance standards for both automotive and aerospace. And let me be clear, getting this right isn't just an option, it's everything.
So, here's our game plan. We'll start by surveying the electromagnetic battlefield we're designing for. You gotta know your enemy, right? Then, we'll get on the same page with the key definitions, EMI and EMC. After that, we dive into the nitty-gritty, the big showdown between automotive and aerospace standards. And we'll wrap it all up with our prime directive, first-time compliance.
First up, the EM battlefield. Before we even think about a single line of code or a single component on a board, we have to respect the environment our product is going to live and survive in. You know, we can't get comfortable designing in a quiet lab. That's not the real world. Our components are going into some of the most electromagnetically hostile places you can imagine. Every single system crammed into a car or a plane is basically shouting, creating this constant storm of interference. Our job is to make sure our designs perform perfectly right in the middle of all that chaos.
Okay, so to even begin to tackle this, we all need to be speaking the exact same language. Let's just quickly lock in the two concepts that define this entire challenge for us, EMI and EMC.
So think of EMI as the villain in our story. It's the unwanted noise. You know, it's that static on the radio, that flicker on a display. It's the disruptive signals our device absolutely must not create. And it's also all the noise from the outside world that it has to be tough enough to completely ignore.
And if EMI is the villain, EMC is the hero. This is our goal. It's the proof that our device can coexist peacefully, that it can play nice with all the other electronics around it. It's like being a good citizen. It doesn't shout over everyone else, but it also doesn't get confused when things get loud. Achieving EMC is our mission.
You know, EMC compliance really just boils down to two critical questions. First, on the emissions side, is our device being too loud? Is it interfering with its neighbors? And second, immunity. Can our device take a punch? Can it still do its job perfectly when the environment gets noisy? We have to nail both.
So, you'd think the challenge is pretty similar for cars and planes, right? Just survive the noise. But this is where it gets interesting, because the rule books for the road and the sky could not be more different.
This is a massive fork in the road for our entire design process. We can't just create one playbook and hope it works for both. It won't. What passes in a car will absolutely fail in a plane, and honestly, sometimes vice versa. Understanding this split is fundamental.
For our automotive work, the name of the game is CISPR 25, but when we're talking aerospace, it's all about DO-160. Two totally different standards, two wildly different worlds of requirements. Let's break them down.
All right, let's hit the road first. When we're designing components for cars, CISPR 25 is the standard we live and breathe.
The big picture here is all about self-preservation. It's about protecting the car's own sensitive receivers, like GPS, Bluetooth, your cell connection, from all the other noisy electronics packed inside. I mean, think about it. The last thing anyone wants is the engine controller knocking out their navigation on the highway.
So, the key takeaway is that auto testing is laser-focused on managing this crowded, noisy little ecosystem inside the vehicle itself. Our designs have to be tough enough to handle everything from current injection and electrostatic discharge to those huge voltage spikes you get when an engine cranks on a cold day. It's a real brawl in there.
Okay, now let's switch gears and look at what it takes to fly. The requirements for airborne equipment, well, they're on a completely different level.
And that quote says it all, doesn't it? This is not a suggestion, it's not a guideline, it is a non-negotiable mandate. It's about safety and mission-critical reliability. There are no second chances when you're 30,000 feet in the air. And here is where you really see just how different these worlds are. Aerospace standards have to account for some truly extreme threats. We're not just worried about the noise from other components. We have to design for massive voltage spikes and, here's the big one, lightning. We have to prove our equipment can survive a nearby lightning strike. That's a threat our car parts will hopefully never have to face.
So, after all that, what does it all mean for us, for the work we do every day? Let's bring it all home and talk about our mission.
I want this quote burned into your minds. This is the bottom line. Failing these tests isn't just a technical problem, it's a financial disaster. It means costly delays, painful redesigns, maybe even recalls. Designing for compliance from day one isn't just good engineering, it's smart business. We have to avoid these failures.
So I'm going to leave you with this one question. It's the question I want you asking yourselves and each other at every single design review, at every stage of the process. Is this design ready for its environment? Whether that environment is on the road or in the sky, our entire success as a team depends on that answer. Thanks, everyone.